Welcome grade 12s. Let's take a look at hormone control of the menstrual cycle. Now, the diagram that you are looking at shows a graph that is divided into 4 sections. Well, let's look at the first section. Now, the first section highlights the gonadotropic hormones from the pituitary gland. Now, FSH and LH children are known as gonadotropic hormones. Why? Because they stimulate the gonads, which are the sex glands. The next section highlights to us the ovarian cycle. Section 3 is showing us the reproductive hormones from the ovary. And section 4 is highlighting to us the uterine cycle. Let's begin with the hormone control of the menstrual cycle. Okay, before we begin, I need you to understand that during a menstrual cycle, children, 2 hormones, the estrogen and the progesterone, control a series of events in the uterus, right? Now, the ovaries are controlled by the FSH, which is the follicle stimulating hormone, as well as the LH, which is the luteinizing hormone, right? Now, the FSH and the LH are both secreted by the pituitary gland, also known as the hypophysis. Now, you will notice, learners, that the levels of these hormones are going to vary at different stages of the menstrual cycle. Throughout the menstrual cycle, the levels of the sex hormones are going to rise and fall. Okay, let's begin with the hormone control of the menstrual cycle. Step 1. We start talking about the pituitary gland. Children, the pituitary gland is also known as the hypophysis, right? Now, this pituitary gland is busy secreting the hormone FSH. What does FSH stand for? Very good. Follicle stimulating hormone. Now, the hypophysis is busy secreting the hormone FSH. So, as the name suggests, what do you think this hormone will be responsible for? Its name again, follicle stimulating hormone. The job of the FSH is to stimulate the development of primary follicles. Where? In the ovary. And by stimulating the development of these primary follicles in the ovary, he is turning them into mature Craffian follicles. So the FSH is stimulating the development of primary follicles in the ovary, right? Into mature follicles known as the Craffian follicles. Inside each of these follicles is a developing ovum. Children, as the follicles are growing and maturing, they are starting to produce increased amounts of a special hormone, and that hormone is called estrogen, right? So what's happening? The follicle stimulating hormone that's being produced by the pituitary gland, right, is busy stimulating the development of primary follicles. Inside each of these follicles is a developing ovum, right? And when these ovum are growing and developing and maturing, they are busy producing increased amounts of estrogen. So when these follicles are busy producing estrogen, we'll find that the estrogen levels are starting to rise. When the estrogen levels start to rise, it has an impact on the endometrium lining of the uterus. The increasing amount of estrogen is going to stimulate the endometrium to thicken again. Okay? And what happens to the endometrium when the estrogen starts to stimulate it? Yes, you'll find that the endometrium or the lining of the uterus is going to become more glandular, right? more vascular. Why? In preparation for the implantation of a fertilized ovum. Right? In preparation for the possible fertilization and implantation, the breasts are going to become more tender and slightly swollen. Why? Because they begin to develop what will become milk-producing glandular tissue. Now, this rising level of estrogen, this increasing level of estrogen now is going to do something. What will it do? It's going to inhibit the pituitary gland now. It's going to prevent the pituitary gland from releasing more FSH, right? What is this estrogen doing? It's going to inhibit or prevent the pituitary gland from producing any more FSH. Why? It wants to inhibit, it wants to prevent the development of more follicles, right? So that only one follicle at a time is becoming mature. Now, the high levels of estrogen, right? Just before day 14, what's going to happen? This estrogen is going to now go and stimulate the pituitary gland or the hypophysis to start secreting another hormone now called LH, which is the luteinizing hormone. And it will stimulate the pituitary to also start producing FSH, which is the follicle stimulating hormone. What's going to happen now? Just before day 14, you will find that the luteinizing hormone as well as the FSH start to peak. They start to rise, right? Which causes the follicle to burst open and release the ovum. This is called ovulation. Still, under the influence of the luteinizing hormone, the ruptured follicle now is going to be transformed into what we call a corpus luteum. Now, the corpus luteum produces the hormone progesterone. So, after ovulation, right, the progesterone is going to be secreted by the corpus luteum, and that is why you see a rise in the level of progesterone. Now something is going to happen. This rise, this increased level of progesterone, right, is going to inhibit the release of FSH and LH by the pituitary gland. Okay, so what's going to happen? The rising level of the progesterone is going to go to the pituitary gland and inhibit it, prevent the gland from producing any more LH or FSH. And then what starts to happen? You will see a decline or a decrease now in the levels of the LH and the FSH. This is a negative feedback mechanism, children, or when some condition in the body changes and mechanisms in the body start producing the opposite effect so that the body returns to normal. Now you will notice that it's not just the estrogen, it's also the progesterone that has an effect on the endometrium lining, right? Both play a role in the thickening of the endometrium. Now, when progesterone inhibited the pituitary from producing any more FSH, it did that for a reason. Why? So that only one follicle at a time is going to be maturing, okay? And when the progesterone inhibited the secretion of the LH, that was also done for a reason. Why? Yes, that was to prevent further ovulation. So after day 14, what do we notice? Yes, we notice that the endometrium thickens considerably. Why? All due to the effects of the estrogen and the progesterone. You will notice that there will be development in the blood capillaries and glands. So the development of the blood capillaries as well as the glands will increase the thickness of the endometrium in preparation for implantation of the fertilized ovum. Now, children, if fertilization does not take place, what happens? You will find that the corpus luteum starts to degenerate and break down and break away from day 24 of the cycle. When this happens to the corpus luteum, what effect will it have on the progesterone then? Well, the production of the estrogen as well as the progesterone now are going to start to decrease. Why? Because the corpus luteum is responsible for secreting progesterone and small amounts of estrogen as well. So if the corpus luteum degenerates and breaks away, you will find that the levels of the progesterone and the levels of the estrogen start to decrease because the corpus luteum is not there anymore to secrete these hormones. What does this lead to? Well, it's going to have an effect on the endometrium, right? It will result in the shedding of the endometrium. What does this cause? This causes menstruation, right? So what happened? The corpus luteum degenerates. Then the progesterone and the estrogen levels started to decrease, and that resulted in menstruation, the breaking down of the endometrium. Now what's going to happen? Due to the lack of progesterone, what's going to happen now? Yes, it's going to have an effect on the FSH and the LH, right? They are no longer going to be inhibited or prevented, right, from being produced. So what's going to happen now? They will be once again produced by the pituitary gland because the progesterone is not there to inhibit their secretion any longer. And then what happens when the FSH and the LH levels start to rise again? You will find that the cycle begins again, where you'll find that new primary follicles are starting to be developed. So because the FSH secretion is no longer inhibited, right, you will find that FSH is going to be released again, right? And this is going to stimulate the development of new follicles, where in the ovary, and the cycle starts all over again. So what have we learnt in our lesson today, children? Yes, we have learnt that the interaction between the different hormones illustrated something to us. It illustrated to us the principle of something called negative feedback. What does negative feedback mean? It means that an increase in the level of one hormone will result in a decrease or the complete inhibition of the secretion of another hormone, right? And where did we see that? We have seen negative feedback in the interaction between the hormones of our menstrual cycle. How did we see that? Let's explain. The first time we have seen negative feedback coming into effect was when we looked at the increased levels of estrogen secreted by the developing Craffian follicle, right? And when this happened, when the estrogen level started to increase, this rising level of the estrogen inhibited the release of FSH by the pituitary gland. And what happened when this took place? It prevented the development of further follicles in the ovary. Another area we have noticed negative feedback coming into play was the increasing levels of the estrogen and progesterone secreted by the corpus luteum, and this inhibited the release of FSH and LH from the hypophysis. When this took place, it prevented the development of any further follicles as well as ovulation. Another area we have noticed negative feedback was when the corpus luteum degenerated. What happened then? The estrogen levels and the progesterone levels in the blood started dropping or decreasing. Therefore, the secretion of FSH and LH is no longer inhibited, so their concentration started to rise or increase, and the process started all over again. I hope you enjoyed our video. Like and subscribe.